Well, hello everybody. It's Mike Prevost here from MikePrevost.com. I want to talk to you today about high intensity interval training and fat burning. And I've noticed lately a couple of articles in some of the more popular fitness websites about HIIT training and fat burning. And, to be honest, they got most of the details wrong. And so I want to clear the record, I guess, a little bit and set the record straight and talk about what really happens in terms of fat burning and high intensity exercise, and talk about the implications a little bit. Okay, we're going to start off with a little bit of physiology, then I'm going to show you some data, and then we're going to wrap up and talk about what does it all mean. So specifically what I want to talk to you about is why we don't burn much fat with high intensity interval training, and then really why it doesn't really matter. But before we get into the details, I want to start off talking about exercise intensity so that we can talk about intensity versus fat burning. So what I have here is an intensity training zone series from the Norwegian Olympic Federation, and it's a training zones that I use with runners most often. I like this training zone system, and it consists of 5 zones, zone 1 through 5. Okay, so real simple. And here on the chart, we have percent max heart rate associated with each zone. We have perception of effort. What does it feel like to train in that zone? And then, for runners, we have the race distance at the zone pace, just to give you an idea, just to kind of orient yourself with the zone a little bit. So for example, zone 1 is 60 to 72% max heart rate. The perception is easy. It feels really easy at zone 1. And it's ultra marathon pace. So, we're talking about a pace that you could hold for 50 plus miles. So it's a real easy effort. As we jump ahead, say down into zone 3, for example, that's a higher heart rate, 82 to 87%. It starts to get somewhat hard. It's about half marathon pace, or a pace you could hold for maybe, say, an hour and a half to 2 hours. Still not hard, but in the middle of that training session, it would start to feel somewhat hard. Okay. And if we go all the way up to zone 5, now we're getting all the way up to maximum heart rate, very hard. You'd be suffering the whole time during a zone 5 effort. And for runners, you run a maximum mile. If your event is the mile, you're running it at about a zone 5 pace. So we got the zones down. So at what intensity effort or what zone is HIIT training normally done? Well, HIIT training is normally done at zone 5 or higher. So zone 5 or higher for HIIT training. So that's pretty high intensity. Now, can you get higher than zone 5? What do I mean by higher than zone 5? Because zone 5 is 100% max heart rate. Well, you can't exceed 100% heart rate, but you could exceed that intensity. All right. So, for example, a 50 meters all-out sprint, that's a higher than zone 5 intensity. But once we get beyond zone 5, we normally don't measure intensity with heart rate anymore, because the efforts are so short, it doesn't leave enough time to accelerate the heart up to maximum heart rate. Okay, so really what I wanted to establish here is just, what intensity is high intensity interval training done, so that we understand the intensity part of it. Okay, now that we understand intensity a little bit, let's start talking about the general trend of fat use and exercise intensity. And here's some notional data here that I have for you on this chart, and let's orient ourselves to the chart a little bit. The vertical axis is percent fuel use, from 0% all the way up to 100%. So that's percent fuel use on the vertical axis. And on the horizontal axis, we have percent maximum heart rate. So higher percent maximum heart rate, higher intensity. Okay. So let's just look at the general trend. What does it look like? It looks like, let's start off with fat, which is the blue line. It looks like fat utilization goes down as exercise intensity goes up. And for carbohydrates, we see the opposite trend. For carbohydrates, carbohydrate utilization goes up as exercise intensity goes up. Okay. So let's start with really low intensity exercise right here. So right here, really low intensity exercise. You can see that you're burning mostly fat and just a little bit of carbohydrates, right? That makes sense. And then, a little bit higher intensity, you can see that at a little bit higher intensity, fat utilization goes down, carb utilization goes up. So that's a trend. That's what happens. At somewhere between 70 and 80% max intensity, we hit an area that we call the fuel crossover point. And at that point, we're using about 50% fat, 50% carbohydrates. And that's normally in about zone 2 or marathon race pace. It's still not a very high intensity, you know. Beyond the fuel crossover point, fat utilization really starts to drop. And, you know, by the time we get to high intensity exercise, you know, fat utilization as a percentage of total calories is pretty minimal. It's very minimal. So let's superimpose our zones on this chart so we can orient ourselves just a little bit better with intensity and fat utilization. Okay, so zone 1, you can see primarily fat with a little bit of carbohydrates. That's really easy intensity. Zone 2, we hit the fuel crossover point, but even at the end, at the upper end of zone 2, fat utilization is really starting to drop. Zone 3, which remember was half marathon race pace, still not high intensity. We really see a big drop off in fat utilization. I mean, especially near the upper end of zone 3. Zone 4, very little fat being used at all. And finally, when we get to the low end of HIIT intensity, you know, we could see that fat utilization is just negligible in zone 5 and above, where high intensity interval training is normally accomplished. So let's start to look at some of the physiology of what's going on and try to explain these effects. Okay, so we're going to start, I want to talk about hormones and intensity just a little bit. So in this graph, the vertical axis is plasma hormone deviation from resting value. So resting value is about here, okay? And the other axis is percent VO2 max intensity. So increasing intensity as we move to the right. So what I want you to notice in real simple terms is these hormones, epinephrine, norepinephrine, cortisol, and glucagon, we'll call them the fight or flight hormones, okay? So our fight or flight hormones, in general, as exercise intensity goes up, their concentration goes up. Insulin has the opposite effect. As exercise intensity goes up, insulin concentration tends to decrease, okay? So higher exercise intensity, increase in fight or flight hormones, higher exercise intensity, decrease in insulin. So what effect do these fight or flight hormones have in the body? So they have some specific metabolic effects, and we're going to talk about those now. And specifically, I want to talk about metabolic effects in the adipocyte or the fat cell and in the liver. All right. So in the adipocyte, you know, fight or flight hormones cause lipolysis, which is the breakdown of triglycerides. Triglycerides are the way we store fat. And we break down the triglycerides into free fatty acid and glycerol. It's basically a triglyceride is free fatty acids and glycerol. So that's what those fight or flight hormones do, okay? And the free fatty acid then hits the plasma and it's available for energy. So that goes right into the bloodstream. So in the liver, lots of things are going on. So one of the things that's happening in the liver is gluconeogenesis from amino acids. That means producing glucose from amino acids. So we break down protein to form glucose. Okay. Now the glycerol that was produced over here in the adipocyte goes to the liver and it's converted to glucose. And glycogen is the way we store carbohydrates in the liver, and it's broken down into individual glucose units, and that contributes to glucose too. So we can see then that the fight or flight hormones, they're increasing glucose and free fatty acid concentrations in the blood. And that should make sense. It's preparing us for action, preparing us for activity by providing energy substrates in the blood. But I want you to notice something. You know, I showed you that fat utilization or lipolysis, it drops with increasing exercise intensity. I also showed you that the fight or flight hormones increase with increasing exercise intensity, and that fight or flight hormones trigger lipolysis. So that should be contradictory. That should sound contradictory. So we have an increase in fight or flight hormones and an increase in lipolysis because of those fight or flight hormones. You know, that's what we would expect normally physiologically, but as exercise intensity increases, we actually see a decrease in lipolysis. So something strange is going on here, and we'll start to explain that next. So this is an overview of lipolysis in the fat cell and the adipocyte, and we're going to start to pick apart that contradictory finding a little bit, but let's first just look at a normal, the normal progression of lipolysis. So, we start with a triglyceride, which is a glycerol and 3 fatty acids, and we have the hormone adipose triglyceride lipase, and it basically breaks off a free fatty acid, okay, which then goes to the plasma, goes to the blood for energy. And we're left with a diglyceride. And then hormone-sensitive lipase breaks off another free fatty acid, which again goes to the plasma, and we're left with a monoglyceride. And then monoglyceride lipase, it breaks off yet another fatty acid, which goes to the plasma and liberates that glycerol, which then goes to the liver. And remember, that produces glucose, right? So just an interesting aside for you, you can actually get glucose from fat. And this is a mechanism through glycerol. It's not a super significant source of glucose, but it can be in the case of, say, ketosis or a really low-fat diet. You can get a significant amount of glycerol and producing a significant amount of glucose. All right, so this is the normal process. Now, this whole process is stimulated by epinephrine. Okay, so epinephrine is an activator of hormone-sensitive lipase. It activates hormone-sensitive lipase. So we showed you that epinephrine concentration increases with increasing exercise intensity, and that insulin, on the other hand, drops with increasing exercise intensity, and insulin inhibits hormone-sensitive lipase. So if you take all this information together, it should be a little bit confusing at this point, because it looks like at high intensity exercise we should have more lipolysis, not less, because insulin's dropping and epinephrine is increasing. But that's not what happens. And in the next slide we'll talk about why that does not happen. Well, in addition to those fight or flight hormones increasing during high intensity exercise, there are some other things that increase that play a significant role here. One is hydrogen ions. So an increase in hydrogen ions is an increased acidification of the plasma, increased acidification of our blood, right? So during high intensity exercise, we have an increase in hydrogen ions. Well, hydrogen ions inhibit hormone-sensitive lipase. They block the action of epinephrine in increasing hormone-sensitive lipase. The other thing we get is an increased concentration of lactate. Lactate tends to drive the resynthesis of triglycerides. Lactate drives this process in that direction. So now we have the accumulation of two substances, lactate and hydrogen ions, both driving this whole process in the opposite direction. Now, I'm not saying that during high intensity exercise you're storing fat, but what I am saying is that during high intensity exercise, because of the increase in hydrogen ions and increase in lactate, instead of seeing more lipolysis, we actually see less lipolysis, because of the inhibition of hormone-sensitive lipase and lactate driving everything, in the opposite direction. And so that explains that sort of not controversial, but that contradictory data that, we would expect lipolysis to be higher, but it's not. And it's not higher because of these two factors. So back to our original slide again, despite the fact that fight or flight hormones are increasing, well, fat burning is decreasing at higher exercise intensities. And again, that's because of the hydrogen ions and the lactate, which are also, much higher at the higher exercise intensities. So now I want to get into the issue of fat burning a little bit. And before we get too deep into fat burning, I need to explain a simple concept to you called the respiratory exchange ratio. It's something that we can measure. So I've measured it many times in the lab, personally, using a metabolic cart. And I don't want to get into too many details about it, but the respiratory exchange ratio is a ratio, and it's simply a ratio of carbon dioxide exhaled divided by oxygen consumed. So it's carbon dioxide produced divided by oxygen consumed. Okay. Also sometimes referred to as respiratory quotient or or respiratory ratio. Those terms are used interchangeably often, even though they're not exactly the same thing, but close enough. We'll call them basically the same. And the relationship I want you to notice is just simple, that as RER decreases, fat utilization increases. Okay, so for example, at an RER of 0.7, we see that our percent calories from carbohydrates is 0. Our percent calories from fat is 100%. So we're burning all fat at an RER of 0.7. At an RER of 0.8, we're at 50-50. And at a high RER of 1.0, we're at 100% carbohydrates and 0 fat. So as RER increases, fat utilization goes down. Okay, so it's something we can measure real easily. Okay, so now let's start looking at some actual data. So this is some data from Paoli et al. Published in 2012. And this is comparing high intensity interval training and traditional training. Traditional is just traditional steady state training. I want to start by looking at the graph on the right, because we just talked about RER, okay? So here's, this axis is the respiratory ratio that we just looked at, okay? And I want to look at one piece at a time. So we're going to look at traditional training first, these two boxes right here. So you can see the RER at time 0 for traditional training, and this is the RER 22 hours later after traditional training. And what you can see is it's dropped just a little bit, but not much, not significantly so. Well, on the other hand, let's look at high intensity interval training. Okay, and what happens? Well, this is the RER pre-training, and you can see it's about the same as the other group. But look at what happens to the RER 22 hours later. The RER is greatly decreased. Okay, that's a pretty significant decrease in RER. What does that mean? Well, our RER is dropped. If the RER is dropped, then fat utilization has increased. So it looks like compared to traditional training, post-training, we get an increase in fat utilization with high-intensity training. So that's a pretty interesting finding. And that's pretty consistent across the board with lots of high-intensity interval training protocols, that we see a shift in RER in the time after training, okay? Now let's look at the other ones. So now I want to look here, because it's also an interesting effect. All right, so let's start with, again, our traditional training boxes over here, okay? So what do we see? This is, in this case, this is resting energy expenditure. So this is metabolic rate. So this is metabolic rate pre-training and post-training, 22 hours post-training. And you could see that metabolic rates increased a little bit, even 22 hours later. Okay, and the presumption is that it was increased a lot immediately post-training, and eventually it started to come back down to baseline, but 22 hours later it still increased. Not a whole lot, but a little bit. And that's in the traditional training. Now let's look here at the high intensity interval training though. So again, resting metabolic rate to start with, about like the other group, but look at what happened. 22 hours later, we have resting metabolic rate is still significantly elevated. And that's a pretty big increase. So a couple of things that we found here. So one of the things we found was that after high intensity interval training compared to traditional training, RER goes down, which means fat utilization goes up. Also, after high intensity training compared to traditional training, energy expenditure is up, our metabolic rate is up, even 22 hours later. So high intensity interval training compared to traditional training increases fat utilization and metabolic rate after exercise, even though we're not burning that much fat during the exercise. Well, that was just one example, but you can comb the research literature and you can find lots of examples of that. The consistent finding then is that the higher the intensity of the exercise session, the greater shift in RER towards fat burning after exercise. Remember, during the exercise session, we're not burning much fat, but we tend to shift to fat burning mode after exercise, and that effect is greater with higher exercise intensities. So a good question to ask at this point is, so what? What's the magnitude of this effect? Is it a big deal, or is it just a tiny number of calories and not anything to really be concerned about? Well, let's take a look. So here's a study from the European Journal of Applied Physiology published in 2002, and we're going to look at a little bit of actual data here. So we're going to look at this graph off to the right, and in the vertical axis is VO2. It's a rate of oxygen consumption in milliliters of oxygen per kilogram of body weight per minute. So when we consume oxygen in order to produce energy. So if we measure oxygen consumption, we're measuring basically metabolic rate. So that's about as far as we need to get into the weeds with that. And here we have pre-test resting metabolic rate. We measured again after day 1 and after day 2. So I want to talk about the exercise session here first. So the exercise sessions here, we're using big structural exercises like power cleans and squats. They were performing on average about 10 repetitions. They were training to failure and then adding a couple of reps in a rest pause fashion, which means you go to failure, you rest a couple seconds, crank out another rep, rest a couple seconds or so, crank out another rep. And they were adding 2 to 4 reps rest pause session to get to that 10 repetitions. Pretty hard, high intensity because of the big whole body barbell movements, the training to failure and the rest pause. So it's pretty hard training, okay? And what happened? Well, you can see where the resting metabolic rate was pre-test. So we call that somewhere around 3.3 right there, right? And you can see a day later, it's significantly elevated. So we're almost at 4. And 2 days later, we're still elevated. So what we see is that for at least 2 days after a training session like that, we have an increased metabolic rate. Now you can expect the R value to have dropped significantly too, and so most of those extra calories would be coming from fat. Now what's the magnitude of this effect? Well, in this particular study, the researchers estimated that it would have been an extra 773 calories after the exercise session ended due to elevated resting metabolic rate. So that's pretty impressive, and that's really significantly more than most people have found. And there's a reason for that. I want to get into that detail next and explain why we don't know as much as we would like to know about this fact. Okay, so here's a made-up graph. It's made up of some of the data I showed you on the previous slide and a little bit of data I added. Okay, so we have metabolic rate on this axis, and then we have resting again, and we have post-exercise here, and then we have another one that I just put in here for reference. It's metabolic rate at your maximum aerobic rate, or at your VO2 max intensity, zone 5 intensity. So here's what I want you to notice. Your metabolic rate at a zone 5 intensity would be somewhere around, 59 milliliters per kilogram per minute. So most high intensity interval training studies that are measuring post-exercise metabolism will use, say, a zone 5 intensity. And then what they do is they watch afterwards and watch metabolic rate decrease over time. And pretty quickly, within an hour and a half, it's somewhere around this post-exercise value. And at some point, we saw from the last study, 2 days later, it was still at this value. So 2 days later, it was not back to resting. At some point, it gets back to resting. Now, here's the problem that we run into. Most researchers who have looked at post-exercise metabolic rate have stopped measuring metabolic rate after an hour to an hour and a half. And why would they do that? Well, they assumed that they were back to resting value again, back to baseline again. And you can see how somebody would make that assumption and how it's easy to make that mistake, because look at the difference, the magnitude and difference between, where you are at maximum exercise versus where you are post-exercise, your resting metabolic rate. And the red horizontal line I put here is at resting value. Look at the tiny little increase above resting value you get post-exercise. It's not that much. And most researchers would look at that and say, we're back to baseline here. But in fact, the researchers in the previous study were smarter than that. And they saw this tiny little bit, and they said, well, if this tiny little increase is still there a day later and 2 days later, that although it's small, it'll really add up. because these values are a per minute value, right? So if you multiply that by 60 to get the value for an hour, and then multiply it by 24 to get the value for a day, you can see that these small differences between these two can add up to a lot of calories. And in the previous slide we showed you it was 724 calories. So, as a result of this issue, we don't have a lot of studies that have looked at long-term, 1 day, 2 day, 3 days post-exercise to determine really how many extra calories you do burn after high-intensity interval training. But we do know we have at least that one study showing, an extra 724 calories is pretty significant. So let's put everything together and draw some conclusions now. So, we know pretty conclusively high-intensity interval training burns very little fat during exercise, and we showed you why that occurs, and we talked about the physiology a little bit, and that's not controversial at all. But we know based on lots of data that HIIT training shifts the respiratory exchange ratio towards more fat burning. So we just shift our body more towards a fat burning mode, and the higher the intensity, the greater the shift towards fat burning. And we also know that high intensity interval training increases resting metabolic rate for at least 2 days, in some cases maybe more. We need more research to really characterize this, but so the end result looks like we don't burn much fat during exercise for high intensity training, but we burn a lot more after exercise. So that's why I say we don't burn much fat during HIIT, but it doesn't really matter because the effects after exercise compensate. So you should be asking now, so is HIIT the best way to train for fat loss then, based on, the physiological mechanisms that we presented here? Well, there have been a number of studies comparing HIIT to traditional long, steady distance exercise. And in general, the data points towards HIIT probably being more effective, although it's not as conclusive as we would like. And it depends on the comparison, what's the duration of the long distance exercise you're comparing to the HIIT. So there's a lot of factors that have to be considered. But, I'm comfortable enough in saying that in general, it seems to be a bit more effective strategy. Although I have to tell you that the long, slow distance cardio has been shown to be effective as well in a number of studies. So, well, there you have it. There's the explanation of why we don't burn much fat during HIIT and why it doesn't really matter. Thanks for listening. I hope you enjoyed the presentation. If you have any follow-up questions, go on over to MikePrevost.com and you can post a question there in the comments section, or you can hit the contact me button and shoot me an email, and I'll try to answer it the best that I can. And also I just want to say that knowledge is wasted if it's not shared. That's the whole reason I'm doing these videos. And if you find it useful, spread the word. Thanks.